Okay, now we're doing question 3 on section 2-1, and we're finding the average rate of change. And the average rate of change is simply the formula for it corresponds to the formula for slope. And now we've got to, so our average rate of change is going to equal the cotan of 3 pi over 4, and the cotan of 3 pi over 4 is -1, minus the cotan of pi over 4, which is 1, and divided by, and x sub 2 in this case is 3 pi over 4 minus pi over 4, and this equals -2 over 2 pi over 4, the difference in these two when 2 goes into 4 twice. So now when we invert and multiply, we get -2 times 2 over pi, which equals -4 over pi. And we're done with that one. Now, once again, we're doing the same problem 3, except we're doing it on the interval pi over 6 to pi over 2. So the cotan of pi over 6 is, so average rate of change, the cotan of pi over 6 is √3. I beg your pardon, the cotan of pi over 2 is 0, and minus, now the cotan of pi over 6 is √3, and downstairs we have pi over 2 minus pi over 6. So let's simplify that. So upstairs we have a minus √3. Downstairs we've got to, we need a common denominator, and that common denominator is going to be 6, so I'll multiply pi over 2 by 3 over 3 to get that common denominator. And so we get minus √3 over 3 pi minus pi all over 6, and so that equals -√3 and divided by, let's see, 3 pi minus pi is 2 pi, and 2 pi over 6 reduces to pi over 3, and when we invert and multiply, we get -3√3 over pi. And now we're doing question 7, and we have to find the slope of the curve. If we graph this, this is a curve, and it's a parabola that's been dropped down 3 units. As a matter of fact, here's what it looks like. And there it is, and this is 0, 3, or -3, 0, -3, and the intercepts are √3, 0, and -√3, 0. Be that as it may, we've got to come up with the slope of the line at the point 2, 1. And so that's going to be about right there. We have to come up with the slope of that line. The secant line, excuse me, the tangent line, but what we're going to do is come up with the slope of the secant line, and then see what happens as h approaches 0. So let's go for it. F of x plus h equals x plus h squared minus 3, and we already know that, given this here, that f of x equals x squared minus 3. So let's expand this guy, and so f of x plus h equals x squared plus 2hx plus h squared minus 3. Now, let's build this equation. So m equals, and in place of f of x plus h, we'll write x squared plus 2hx plus h squared minus 3 minus, in place of f of x, we'll install x squared minus 3. X squared minus 3, and that's all over h. So that equals x squared plus 2hx plus h squared minus 3 minus x squared, and a minus times a minus is a plus 3, all over h. Now notice these 3's add out, and so do the x squareds. And so we get 2hx plus h squared all over h. And now we'll factor an h out of each term. And we get 2x plus h all over h. And these h's divide out. And now, so we've got m equals 2x plus h. And now we'll let h go to 0. So we're going to let h approach 0. Well, it can just be 0. No harm done. No division by 0 here. So then if we do that, m equals 2x as h goes to 0. Now to find the slope at x equals 2, our ordered pair is 2, 1. So m is going to equal 2 times 2, the x-coordinate, which equals 4. So now we've found the slope of the curve at the point 2, 1. Let's go beyond that, and so I'm going to warehouse that, put it right here. M of 2, 1, or excuse, I'm going to rewrite that in a different way. M relative to the point 2, 1 equals 4. Now let's erase the rest of it, and we'll come up with the equation of the tangent line to the curve at that point. And all we use is the point-slope form of the line, so we're going to have y minus the y-coordinates 1 equals, the slope is 4 times x minus 2, point-slope form of the line. So y minus 1 equals 4x, and 4 times 2 is 8, minus 8. Now let's add 1 to both sides. If we add 1 to this side, we just get a y. And if we add 1 to negative 8, we get negative 7. And there's the equation of the tangent line to the curve at this point. And we are